Section 5.4, graphs of sine and cosine function. A function f is periodic if there's a positive number p called the period of f such that f of x plus p is equal to f of x for all x in the domain of f. What they're saying is, if it's periodic, if you take this and add 4 to it and move this over 4 either way, it's the same graph. So I hope you can see that if you take this graph here, it'll repeat itself right after that. So if you take this, what I just drew, it repeats itself. Okay? So it just keeps repeating itself. The value p is called the period of the function. So here's my graph right here. This is a periodic graph. It repeats itself. It starts at 0, it goes up to 2, goes back down to 0, down to -2, back up to 0, and then it repeats itself. To find the period length, we look at our x values. So our period length is 4, because at p equals 4, it starts repeating itself. The sine and cosine functions are also both periodic functions. And remember, think about the unit circle. You went around a whole circle, 2 pi, and then it started repeating itself. It was the same thing. So they both have a period of 2 pi. This is what the sine curve looks like. It repeats itself. The sine curve has a period of 2 pi. It starts at 0 here. It goes up to 1, back down to 0, to -1, and back to 0. The sine curves have the zeros, if you can see, at the beginning, middle, and end. So at the point 0, 0, at the point pi, 0, and at the end of the cycle, 2 pi 0. So beginning, middle, and end are the zeros. The maximum happens 1/4 of the way through the sine curve at pi over 2, 1. The minimum happens, the lowest value, 3/4 of the way through the curve. So 3/4 of 2 pi, so if you take 3/4 times 2 pi, you get 3 pi over 2. So at 3 pi over 2, -1. When you look at this, the domain, if you look at it from right to left, goes forever because it keeps repeating itself. So it's -infinity to positive infinity. Range are your y values. It goes up to a +1, it goes down to -1. So your range is from -1 to +1. Let me show you where some of these numbers come from. Think about the unit circle. And I'm going to draw the unit. Think about the unit circle over here. With the unit circle, I'm starting right here at 0. Sine of theta is y over r. So theta is 0. At 0 here, sine is 0 over 1, which is 0. Okay? When I'm at, let's say, 30 degrees, so if this were 30 degrees, or pi over 6 radians, remember that curve, or that triangle, is a 1, 2, radical 3 triangle. So there, the sine at 30 degrees, or at pi over 6, is 1/2. At pi over 4, if pi over 4, the triangle is 1, 1, radical 2. So it's 1 over radical 2, or radical 2 over 2. And so if I graph these points, 0, 0 might be there. Pi over 6 might be about here. Pi over 4 might be, I don't know, about here. And you can keep going, pick different points. Pi over 2, remember at pi over 2 I'm up here at the point 0, 1. So at pi over 2 I'm 1 over 1, or 1. So at pi over 2, which is right here, I'm up here at the maximum 1, and so forth. So this part is the first quadrant. It's going around the unit circle right there. This part of the curve, if I keep going around the circle, is that part. So if I'm at 2/3 pi, or 5/6 pi, or 3/4, all those up to pi. At pi, I'm in 0 now. And then continue around the circle in the third quadrant. This is stuff from the unit circle, third quadrant. And that's one is black. This is from the fourth quadrant of the unit circle. And you could just keep doing a t-chart with theta for my x and y over r for my y. You could get all the points where they are around there. So if you keep picking all the angles. And then it repeats itself because you finished a circle and now I'm going to do another circle. So that's where those numbers come from. So what we're doing is we're taking the unit circle and we're translating that to the Cartesian coordinate system. So this is going positive one circle around. Here's my second circle around the unit circle. This is going negative unit circle. So this is going, if I go this way around the unit circle, that's this one right here, and so forth. Okay, so that's where sine's coming from. You can do the same thing with cosine. You could do the unit circle and say, okay, at 0, cosine is 1, so that's why I'm at this point. And so this is from the first quadrant of the unit circle. This is from the second quadrant of the unit circle. There's from the third quadrant of the unit circle. There's from the fourth quadrant and so forth, and then it keeps repeating itself. This also has a period of 2 pi. The 0 marks are a fourth of the way through the period and 3/4 of the way through. And 1/4 of pi over 2, or I'm sorry, 1/4 of 2 pi, because 2 pi is a whole period, is pi over 2. So pi over 2, 0, there's a 0. And 3/4 of, remember what of means? 3/4 of a period. That's how you get 3 pi over 2, comma 0. The maximum, beginning and end points. And the minimum is halfway through the period. So at pi, -1. Again, domain and range are the same as your sine curve. So really, I don't want you to remember the exact points. What I do want you to remember is at the beginning and end are my maximums. Because what if I give you a cosine that has a different equation for cosine that has maybe a period of pi? Then you have to know, oh, my maximums then are 0 and pi, because it's beginning and end. So just remember, maximums are beginning and end for cosine, minimums halfway through, 1/4 and 3/4 of the way through the period, you'll get the zeros. Whereas sine, beginning, middle, and end are zeros, 1/4 of the way through is the maximum, 3/4 of the way through is the minimum. So there's sine and cosine. Remember what we said about even functions and odd functions from a previous section in chapter 2. A function f is called even if for each x in the domain of f, negative x is also in the domain of f. So that means that f of negative x is equal to f of x. And remember that this is symmetrical with respect to the y-axis. Odd function, f of negative x will equal negative f of x. And this graph, if you graphed it, it'll look symmetric with respect to the origin. So sine is an odd function, and cosine ends up to be an even function. Think of the unit circle. If I go this way, or I go this way, if I go this way, and anywhere from 0 to 90, sine is positive. But if I go in the negative direction, I'm in this quadrant here, sine is negative there. Okay? Or if I'm in this quadrant right here, if I go negative that way, I end up in this quadrant. Sine's positive up here, negative down there. So sine is odd. Cosine, if I go negative t, it's really the same as the positive. Or if I'm somewhere in the second quadrant, I'd still get, like here, I'd get negative cosine. So they would equal. So cosine of negative t is the same thing as cosine of t. So if I do cosine of, if this is my negative t, it's the same as cosine of positive t, because cosine is negative in both of them. The period, if a period of a graph has a maximum value m, capital M, and a minimum value little m, then the amplitude is A is equal to the maximum minus the minimum divided by 2. So you need to know that formula. So sine and cosine, maximum's 1, minimum's negative 1. So 1 minus a negative 1 divided by 2 gives you 1. So sine and cosine both have amplitudes of 1. And remember from previous sections, stretching and shrinking graphs vertically and horizontally. You're going to use this with the sines and cosines. So remember that. We're going back to this. So if I have some function y is equal to a sine of bx, or y is equal to a cosine of bx, a is not 0 and b is greater than 0. The amplitude would be the absolute value of my a, so the number in front of there, the positive of it, and the period is 2 pi over b, whatever number is in front of there. So you need those formulas, so don't forget those formulas. So now let's graph some examples. I want to graph y is equal to 3 sine of 2x. If I were going to do this first, I would say to myself, I have a sine curve. Beginning, middle, and end of the cycle are my zeros. 1/4 of the way through is my maximum, and 3/4 of the way through is my minimum. Okay, so you remember that. But I don't have a period of 2 pi. I have a period of 2 pi over b. So you have to figure out what your period is. And I don't have an amplitude of 1, I have an amplitude of a. So amplitude is a, so the amplitude is 3, and the period length is 2 pi over b, which is 2. So my period length is pi. So we have beginning, middle, and end. We have our zeros. So at the beginning is 0, 0, and the end would be pi 0, right? So halfway through, half of pi is pi over 2, 0. So there are my zeros. My maximum is 1/4 of the way through the period. So 1/4 of pi gives me pi over 4, maximum at 3. Minimum is 3/4 of the way. So 3/4 of pi, 3/4 times pi, would give me 3 pi over 4, negative 3. So if I were going to graph this, here's how I like to graph it. Remember, stuff happens beginning, middle, and end 1/4 of the way or 3/4 of the way. So I like to just divide it into 4s. 1, 2, 3, 4. I call the last line my period, which is pi. So when I graph it, beginning, 1, 2, 3, 4. If I could divide it into 4s, divide it into thirds. Beginning, middle, and end are my zeros. 1/4 of the way up is my maximum, so I might do this as, this is 1, that was pi. You can have different scales. So the maximum is 1/4 of the way through the period. 3/4 of the way through the period is my minimum. So now I have a graph that looks something like this. This is just one period. If I were going to continue with the graph, the next dash right here would be coming up to my maximum. So it would be something like this. And do the same thing here. 1, 2, 3, 4. So here, one minimum, a 0. That's a 0 too, a maximum. 1, 2, 3. So there. So there is what the 3 sine of 2x looks like. And pick up your calculator now and put it on your calculator and see if you get a graph that looks like this. You might want to change your graph so your x-axis might go from a little more than pi, 1 half, 2 halves, maybe 3 halves pi, or 3, not 1/4, 2/4, 3/4, 4/4, 5/4 pi. So you could do 5 pi over 4 for your maximum, and maybe negative 5 pi over 4 for your minimum, and then figure out what your y is. So if you go to window, adjust it, and make sure the graph looks like this. So when you're doing your homework, do the graph first, and then pick up your calculator and type it right in your calculator. And that's what it should look like. That's what we drew. The next graph, y is equal to 1/2 cosine of 3x. Remember, amplitude's a number in front, so now my amplitude's a half, and my period is 2 pi over b, so 2 pi over 3, okay? So we know that. 1/2 and 2 pi over 3. Basic cosine graph, beginning and end have its maximum points. In the middle is its minimum value. Okay, and 1/4 of the way and 3/4 of the way, we have our zeros. Again, I like to 1, 2, 3, 4. Divide it into fourths. This is, I'm going to label this as 2 pi over 3. Okay? 1, 2, 3, 4. So this is negative 2 pi over 3. Amplitude's a half. I don't want it to be so little, so I'm just going to call that a half. And this is negative a half. So if I were graphing it, remember, beginning and end are my maximum. Halfway through is my minimum. 1/4 of the way and 3/4 of the way are my zeros. So it looks something like this. And you can keep graphing it. Hold on. 0. It's right there. Okay? So there's what the graph looks like. The maximums are at the beginning point, which is 0, 1/2, and the end point, 2 pi over 3, 1/2. The minimum is halfway through a period, and remember a period is 2 pi over 3, so half of 2 pi over 3 gives me pi over 3. So pi over 3 negative a half. And 1/4 of a period, which is pi over 6. So pi over 6, 0. And 1/4 through 3/4, 3/4 of a period. Again, 3's cancel out 2's, so this ends up to be pi over 2. So pi over 2, 0. That's why I want you to remember halfway, 1/4 of the way, because 1/4 of means multiply, 3/4 of means multiply. There's my graph. Graph y is equal to negative 2 sine of pi over 2x. Again, sine, basic sine curve, beginning, middle, and end, have my zeros. Maximum 1/4 of the way through, minimum 3/4 of the way through. Amplitude is absolute value of the number in front. So absolute value of negative 2 gives me 2. And my period is 2 pi over 2. Remember, numerator divided by denominator is the same thing as numerator times the reciprocal of the denominator. So that ends up to be 4. So my period is 4. Notice the negative in front of the sign. The y is going from positive to negative. So this is a reflection around the x-axis. So instead of the graph looking something like this, the graph will look something like this. Okay? So instead of the 1/4 of the way through being a maximum, 1/4 of the way through will be a minimum now. Okay? So again, I like to divide it into fourths. 1, 2, 3, 4. This is my period, 4. Beginning, middle, and end are my zeros. A quarter of the way through is traditionally my maximum, but a quarter of the way through now is going to be my minimum. And I'm going to call this 1, 2. 1, 2. So a quarter of the way through I'm at -2. 3/4 of the way I'm at +2. So I have my zeros at 0, 2, 2, I'm sorry, yes. My zeros at 0, 0, 2, 0, and 4, 0. The minimum at 1, -2. The maximum at 3, +2. So if you graphed it, it would look something like this. And if you were continuing to graph it, there'd be a minimum there. 1, 2, 3, 4. Beginning, middle, and end are the zeros. 1, 2, there's a maximum, so it's something like this. Minimum right there. And again, there's a maximum. Get out your calculator, graph it, and see if it looks like this. Here's my curve. If I were going to graph y is equal to -3 cosine of pi over 4 or pi over 5 times x. Basic cosine graph. Beginning and end have my maximums. My minimum is halfway through. And a quarter of the way through and 3/4 of the way through the period will be my zeros. But with the negative sign in front, it's reflected around the x-axis. So instead of the graph looking something like that, and there's the rest of it, going on forever, it looks something like this. Okay? So, amplitude is 3. Period is 2 pi over b, 2 pi over pi over 5, which is 2 pi times 5 over pi. So the period is 10. Minimums now are at the beginning and end. So at the beginning and end are my minimums. So at 0 minimum, amplitude's 3, so I'll go down to -3. So the minimums are at 0, -3. And at the end of my period's 10, at 10, -3. The maximum point is halfway through the period, so 1/2 of 10 gives me 5, so at 5, 3 is my maximum. The zeros are 1/4 of the way through and 3/4 of the way through. So 1/4 of 10 and 3/4 of 10 give me 2.5 and 7.5. If you want, you could also do 10, if you wanted 10/4, 1/4, 10/4, 5/2. You can just write it as 5/2 you want. And 3/4 of 10. You could write 3/4 times 10 and then reduce it to, I'll show you, 3/4 times 10, and then it reduces to 5, which is 15/2, which is still 7.5. Okay, so if I were going to graph it, again, I like to do 2, 4, there. This is 10. That's 5. Okay? I'm going to do, it goes up to 3, so I'm just going to do, that's 3. That's -3. So, beginning and end were traditionally our maximums. Now I said that there are minimums. So we have minimums, beginning and end. Halfway through we have a maximum. Our zeros are 1/4 of the way through. So it looks something like this. And if I were going to finish it, same pattern. So right there, there. So now that's a 0, that's a maximum. And that's a minimum. And there's my graph. Determining an equation from a graph. Now we can look at the graph and say, okay, what is my amplitude, what's my period of each function? And then we can write an equation. So when you look at this, it starts at 0, so I think the easiest one would be a sine. But you don't have to do it as a sine, you could do it as a cosine moved. but I think the easiest would be a sine curve, because beginning, middle, and end. Beginning 0. It begins at 0, 0. The amplitude, if this is 2, then that has to go up to 3, it looks like. So the amplitude is 3. And 1 period is, that's supposed to be 0.5. So it's half a pi. Or pi over 2, you could write it as. So the equation will have this form. A sine of bx. Since the amplitude is 3, A will equal 3. And because the period is pi over 2, or 1/2, period is equal to 2 pi over b. So my period is, instead of that, you could put pi over 2. And then if you want, you could cross multiply and solve the equation. So if you want to cross multiply and solve for b, you could do that. And so when you do that, you'll get b is equal to 4. So you have b times pi is equal to 2 times 2 pi, and then you divide by pi. So b is equal to 2 times 2, or 4. So the equation is y is equal to a, which is 3, sine of b, which is 4, x. You could have done a cosine curve, but the problem with the cosine curve is it's moved. So with the x, you would have a plus or minus how much you move it. This graph right here, it looks a little bit like, but not 100% like, it looks a little bit like a cosine curve, except not starting at the maximum, it starts at the minimum. So you could say, okay, this is a cosine curve, but it's probably a negative cosine. So it's a cosine curve because it doesn't begin at 0, 0. It's reflected around the x-axis, like I said, because it starts at the negative, the minimum, not the maximum. So the equation will have the form a cosine of bx. A will be negative because of the reflection. So when you look here, the amplitude goes up to 2 and down to negative 2, so the amplitude is 2. So A is negative 2. Period is 2 pi over b. And when you look at this, let's see what the period looks like. The period actually looks like it's 1. Since the period's 1, you have 1 is equal to 2 pi over b, so b ends up to be 2 pi. So the equation is y is equal to a, which is negative 2, cosine of 2 pi x. And you're done. We already know how to translate from graphs from our previous study from functions. And remember, this is vertically going up and down, k units. H is right and left, horizontally. So if we're going to do sine and cosine, same type of idea, y minus k. So this is right and left movement. X minus, or I'm sorry, this is up and down movement. X minus h, this will be right and left movement. And horizontal movement, if they ask what is the phase shift, they're talking about the horizontal movement. So the phase shift is right here. You're going h units either right or left. So that's your phase shift. So if I was going to try another problem, I want to graph the function y minus 3 is equal to 2 sine of pi x minus 1. So the first thing I would do is say, okay, what is my amplitude? The sine graph, my amplitude is 2. My period is 2 pi over b, and b is still that number in front of the x, which is pi. So 2 pi over pi, which is 2. So I would start by just graphing that. I would graph just y is equal to 2 sine of pi x first. So that's what you start with. And then after you graph that, then I would do my movement. So the zeros, it's a sine graph, beginning, middle, and end. So at 0, 0, 1, 0, and 2, 0. A quarter of the way through, so 1/4 of 2 is half. So at a half, 2 is the max. And 3/4 of 2 is 1.5, is my negative. So my negative is at 1.5 of the way through, or 1.5 where the x is, negative 2. So first let's look at that. So if I were going to graph that, 1, 2, 3, 4. Beginning, middle, and end are my zeros. And remember, this is 2. My maximum happens a quarter of the way through. So at 0.5, I'm at my maximum. At 1.5, I'm at my minimum. So it looks something like this. Okay, and it could repeat itself. So that's what I would do first. Graph y is equal to 2 sine of pi x. And then after you graph that, then I would say to myself, okay, what does this do to it? I hope you know that that moves it up 3. And then I'd say, okay, what does this do to it? I hope you know that that moves it right 1. So what I like to do is I like to list my points. Beginning, middle, and end are my zeros. A quarter of the way through is my maximum. And 3/4 of the way through, which is 3/2, is my minimum. So I just labeled all my critical points there. And now I'm going to look, if I go up 3 and to the right 1. If I go right 1, I would be adding 1 to my x. And if I went up 3, I would be adding 3 to my y. So this is the point that I'm adding to my original points. So my new point would be 1, 3. This point here would be 1.5, 5. This would be 2, 3. This would be 3/2, 5/2, or 2.5. 5/2, 3. 3 plus a negative 2 is positive 1. 2 plus 1 is 3. And 3 plus 0 is 3. So there are my new points. This, remember, was 0, 0. This is 2. Okay? So now, when you move it, that's 2. This is 1. So make sure you're careful the way you're using it, because I have different scales. I would go 1 to the right. So this point right here goes 1 to the right, and it goes up 3. So this point goes up 3. 1, 2, 3. And like I said, I'm at the point 1, 3. And just do that for all the points. This point right here goes 1 to the right and up 3. This point right here goes, I'm sorry, yes, 1 to the right, sorry, 1 to the right, 1's here, up 3. 1, 2, 3. If I could draw the point right, it's not that point, it's this point. I don't know why it didn't look right. There. 1 to the right and up 3. 1, 2, 3. Sorry about that. Different color on the black this time. This point right here, 1 to the right, 1, 2, 3. And so my new graph is something like this. There's that. So it goes something like that. And 1 over would be up here. And 1 over would be right there. There's this down here. So it would be something like this. There. And it just keeps following the pattern. Okay? And there's the graph of it. It's the same thing. Okay? So you translate a graph by moving 3 units up and 1 unit to the right. And here are the points that I had listed on the previous page. The same thing I had listed on the previous page. Okay? So those are my points. Same 3, 3, 2.5, 1, and so forth. Now let's graph the function y plus 2 is equal to 4 cosine of pi over 4 times the quantity x plus 1. First we're going to graph y is equal to cosine of pi over 4x translated. Actually we're going to graph 4, the amplitude in front of it, and then we're going to translate it. So the amplitude is 4. The period length is 2 pi over 4, which is 2 pi times 4 over pi, which gives me 8. And that's the new graph will be translated right and left movement, it would go left 1. Up and down movement, it would go down 2. Okay? So left 1, down 2. So left 1, down 2. If I go left, it's a negative 1. And if I go down 2, it's minus 2. That's my x movement, my y movement. So that's the point that I'm going to add to all my critical points. Cosine curve. Beginning and end are usually my maximums, and they're still my maximums because the amplitude is positive, or the amplitude is 4, but it has a plus 4 in front of it, not a negative 4. So beginning and end are my maximum points. So at 0, 4 and 8, 4 are my beginning and end of the curve. Minimum is halfway through, so half of 8 is 4, so at 4, negative 4 is my minimum. A quarter of the way through, so 1/4 of 8, and 3/4 of the way through, so 3/4 of 8 is 6. I'm at my zeros. So I usually like to graph those first, or at least get those points first. So maximum is beginning and end, 8, 4. Minimum is halfway through, so it's 4, negative 4. Zeros are at 2, 0, and 6, 0. So now that I have my points listed, 0, 4, 2, 0, 4, negative 4, 6, 0, and 8, 4, I am going to add my movement, which is, I'm going to add negative 1, negative 2 to all of these. I'm going to add that point. And my new point, when I add that, will be 0 plus a negative 1 is negative 1. 4 and negative 2 is positive 2. 2 and negative 1 is 1. 0 and negative 2 is negative 2. 4 and negative 1 is 3. Negative 4, negative 2 is negative 6. 6 and negative 1 is 5. 0 and negative 2 is negative 2. 8 and negative 1 is 7. 4 and negative 2 is 2. Okay? So my graph, which might have originally been divided in the force, my graph, which might have been originally, let's see if I move it 2 down, there's enough. I'll just do this as amplitude of 4. So I think I'll just do 3, 4. Well, I get enough. 1, 2, 3, 4. It'll go off the graph. So I'm going to do, that's 2 and that's 4. Okay? So original graph, beginning and end were maximums. Halfway through is the minimum. So the original graph was something like this. Okay? What I'm going to do is take each point. So I took this point right here, and I moved it 1 unit to the left. And remember, this right here is 8. Period was 8. Each block is 2 units. So I moved it 1 to the left and 2 down. So each point, just move 1 to the left and 2 down. So graph all those points. So negative 1, 2 I would graph. Actually, I'm going to do it in a different color. So negative 1, 2, 1, negative 2, and so forth. And you'll get the new graph. And there's some of the graphs right there, pictures there. Translated by moving each point 2 units down, 1 unit to the left. And that's what I did. Negative 1, negative 2. And here are the points that I had written on the previous page. Oops, wrong way. Negative 1, 2. 7, 2 is my last point. 3, negative 6. 1, negative 2. 1, negative 2, and the 5, negative 2. Okay, so there they are. Graph y is equal to 3 cosine of 4x minus pi. Now I'm going to move it pi units. A is 3. The period is 2 pi over 4, which is pi over 2. I'm shifting it right pi units. I'm not shifting it up or down. So, if I were doing this, pi over 2, 1, 2, 3, 4, but I'm going to divide it into fours this way. 1, 2, 3, 4. This is pi over 2. And the reason I did that is because I'm moving it pi units. And if I did it pi over 4 or 2 would have been here. I wanted it a little better of a graph. So there's pi, 2, 3, 4. There's 1/2, 2/2, 3/2. 1, 2, 3, 4. And there's 4/2, so there's 2 pi. So there are my force divided out. And if I graph the original graph, my amplitude is 3. And I guess I will do 1, 2, 3 because I'm not moving it up or down. This is a cosine graph, so the maximum points are at the beginning and the end. The minimum point is halfway through, and my zeros are a quarter of the way through. So if I was going to do it, it would be something like this is my regular graph. And so forth. I could keep going. 1/4. There's that. There's that. Maximum again. And it keeps repeating itself forever. But I'm going to move it now. So there's my points that I graphed for you out here. And let me label the points. 0, 3 is the maximum, and also pi over 2, 3 is the maximum. Halfway through, so that's pi over 4 is my minimum. A quarter of the way through, so 1/4 of pi over 2, which is pi over 8. I have a 0. And 3/4 of the way through, I have another 0. Okay? I'm moving it pi to the right. So I'm going to add pi to my x. I'm not adding anything to my y. I'm going to add pi. But here now I'm going to call it 8 over 8. Here I'm going to call this 4 over 4. Here I'm going to call this 8 over 8. Still pi. Here I'm going to call this 2 over 2, because that's still pi. So when I have my new points, I'm at pi 3. Pi over 8 plus 8 pi over 8 is 9 pi over 8, 0. Pi over 4 and 4 pi is 5 pi over 4, negative 3. 3/8 and 8/8 is 11/8 pi, 0 plus 0, 0. 2 pi over 2, and pi over 2 is 3 pi over 2. 3 and zeros, 3. So there are my new points. So I'm taking this point right here, and I'm moving it pi to the right. So it's moving right to here. This point right here is moving right here. This point right here is moving right there. And if I would have continued this graph here, minimum, here's that, maximum, there. It's the same graph. It's really the same exact graph. If you graph them on your calculator, you'll see that. That's what I said right here. Shift all points to the right. Actually, the same graph as the one before, translated. And the reason is, it's because we shifted it a multiple of a period. So I shifted a multiple of pi over 2. So I really shifted it 2 periods over. So if you shifted a period over either way or multiple periods, it'll be the same graph. Give an equation for the following. I have a graph here. I want to give an equation for it. First thing I would do is figure out, do I want to do sine or cosine? Because you could do either sine or cosine. Okay? But whatever you do, sine or cosine, the amplitude and period length are the same. So when I look at this, I go up to 1 and down to -3. Okay? Remember, the formula for amplitude was maximum minus minimum divided by 2. Maximum minus minimum divided by 2. My maximum is 1. My minimum is -3 divided by 2. 1 minus a -3 is 4 divided by 2, which gives me 2. And then when you look at the graph, try to figure out where this graph repeats itself. You can pick a maximum point, you can pick a minimum point, you could pick halfway between 2 points if you want. It doesn't really matter. Whatever you think is the best way to look at it. Okay? And if I do halfway to halfway, there's 1 period right there. I hope you can see that that's 1 and that's 7. The difference between 7 and 1 is 6. So my period is 6. So my period length is 6. And remember that 6 will equal 2 pi over b. So if I solve this for b, I'll get b is equal to 2 pi over 6 or pi over 3. So our equation has a form of the amplitude 2 sine of pi over 3x or 2 cosine of pi over 3x. That's before any translations. It's before any translations. If I was going to do cosine, sine graph, remember sine, beginning, middle, and end are my zeros. So here's a 0 here. So that graph was translated 1 to the right. So if I was going to do the sine graph translated, I'm going 1 to the right. So with my x there, I would have x minus 1. And I'm going 1 unit down. So here with the y, I'd have a y plus 2. So you could do that. And that's what I wrote somewhere here. Let's see. Yeah. Right, minus 1, down, plus 1. Or, if you want to look at the cosine graph, it starts at a maximum. So you could either use this point as my maximum. I'll use that one. If this is 2 and this is 3, this is 2.5. So my maximum amplitude was, 2. So that's where a cosine graph would start. So I'm going 2.5 this way and 1 down that way. And that's where you get the 2.5 to the right, 1 down. So 2.5 to the right with the cosine right here would be x minus 2.5, and down 1 would be the y plus 1. These two are not the only solutions. There are multiple solutions. I'm going to stop for now, and I'm going to put the last one on tomorrow's video.